Hey everyone, it's Justin again. In the first half of this unit, we learned about a special product called a difference of squares. In this video, you'll learn how to factor those special polynomials. If you still have your notes from the difference of squares lesson, get them out because they're going to be super helpful in this lesson. At the end of this lesson, you will be able to recognize and factor binomial differences of squares. In order to learn that skill, first we'll review what a difference of squares is. Then we'll take a look at the rule for factoring a difference of squares and why it works. Then we'll practice the rule using some quick examples, and you'll have a chance to try it yourself. First, let's remember what difference of squares means. A difference of squares is a polynomial consisting of one squared value being subtracted from another. The name actually says exactly what it is: the difference of two squares. The best way to look at a difference of squares polynomial is as a quadratic function where the middle coefficient is 0. From here, we could treat this as a regular factorable quadratic with one major hint to help us out. The combination has to add up to 0. This means the numbers have to be opposites, a negative and a positive of the same value. This makes the whole process a whole lot easier because we don't even need to worry about any combinations that don't follow this pattern. So without having to do much math at all, we found the factors to be x minus 3 and x plus 3. The general rule for factoring a difference of squares is that the factors both have the roots of the original squares, one with a plus and one with a minus. It's that easy. So let's do a few examples. How would we factor this? You might see that leading coefficient and be tempted to pull out a GCF, except there isn't a GCF. Neither term has anything in common. But that's okay, because this is a difference of squares. 2x squared makes 4x squared, and 5 squared is 25. So the factors of this difference of squares are 2x plus 5 and 2x minus 5. This binomial isn't a difference of squares. No integer can be squared to make 6 or 96. But both of these terms are divisible by 6, which means we can pull out a GCF. Now we see a difference of squares, the square of x and the square of 4, which means by the rule of factoring a difference of squares, the factors will be x plus 4 and x minus 4, along with that 6 that we factored out at the beginning. Try this one yourself. Pause the video and factor this difference of squares. The squares in this difference of squares are 7x and 1. So then the factors are 7x minus 1 and 7x plus 1. A difference of squares is probably the easiest type of polynomial to factor, but you have to be able to recognize them first. Practice makes perfect. In the next lesson, we're going to learn to recognize and factor trinomials that are perfect squares of a binomial. See you then.